Hi, I'm Anthony Pascali from Cative Technologies.
And I'm JD.
Welcome to part 5 of our Discovery Live 6-part series. If you happen to miss any of the previous 4, you can find those on our YouTube channel, where I'd be happy to email those to you. Discovery Live is primarily used by design engineers for quick design and quick simulation. If you would like to do a more high-fidelity simulation or something more intricate, we offer this entire suite of ANSYS tools. Today we're going to be covering the 3D design portion of it from Discovery Live. We also have this structure package, optics, fluids, and this whole electronics portfolio. In addition, we have our semiconductor package, embedded software, and systems. We'd be happy to showcase any of those or do a demo for anybody that's interested in seeing that. If after today's webinar you see Discovery Live and are excited to see it or try it, which I'm sure you will, you'd be more than welcome to email me at anthony.pascali@cative.com or call me and I'll send you over a free trial of Discovery Live. For the first 15 people that do that, I will also include free training. Now, JD.
For today's webinar, we're going to use Discovery Live to optimize and design a server computer by simulating 2 types of physics, thermal and fluid dynamics. Assume that you're a designer for a PC enclosure. You just designed a tightly packed computer assembly and would like to study the heat flow in and out of your system. You also have a design review in 8 hours. With Discovery Live, we can optimize our design in a fraction of that time. The following slide illustrates the boundary conditions for our computer. The goal is to remove internal heat being generated by our 2 PCBs. We will start by designing a heatsink to conduct and convect the heat so that it can flow out of our system. Let's begin. Sorry, the volume was muted. So we start by opening our CAD assembly in Discovery Live. We can quickly initiate a thermal study with a few clicks and assign material properties to individual parts. Here we select silicon for our PCB processor. I'm sorry, we're having some technical difficulties. I'm going to re-explain what we were just doing right now. So in Discovery Live, we have the capability to chart our changes in real time. You can see on the y-axis of the chart, we have our temperatures of the silicon chip. The y-axis tracks each time we make a design change. This allows us to see how each of our design changes affects our processor's temperature. As we start to add new parts to our design, we can assign them material properties. Discovery Live allows us to select specific parts in our assembly to be in the simulation. For this instance, we have selected the silicon chip and heatsink. Therefore, the simulation results and design changes will only be captured for these 2 parts. You can see that even adding a block of copper lowered our temperatures significantly. We will further optimize our design by adding pins to a thin base plate. This will give our heatsink more surface area to convect the heat. Thanks to the useful tools in the Discovery Live, we can easily pattern our pins across a surface. Discovery Live will automatically calculate a pattern on the selected surface. If needed, we can also make our own custom pattern similar to various CAD softwares. The square pins did a great job at reducing our temperatures, but it's possible to get more surface area using a larger quantity of rectangular fins. Once again, as we make these changes, our results are being captured in our temperature chart to the top right. The following render shows us the surface temperature of the copper heatsink as it conducts and transfers heat away from the silicon chip. There are various rendering options for thermal studies. Creating section views to see internal temperatures are just a few clicks away. With the power of Discovery Live, we were able to explore and optimize the design of our heatsink within 3 minutes. Now that we've completed our heatsink, let's explore some other design options and their results. The following slide shows 4 other heatsink designs that we explored, each taking less than 3 minutes to design. From the table shown, we can see the temperatures were reduced with the more surface area the heatsink had. By comparing heatsink design number 1 and heatsink design number 4, we managed to reduce temperatures by 40%. Designing our heatsink was only the beginning. We have to design a method to extract this heat out of our system. What better way to do this than perform a CFD analysis? At the start of our simulation, we need to model a fluid domain around our electronic components. Afterwards, we will form split lines directly on the fluid domain to represent our inlet and outlet boundary conditions. Let's get started. Using the design features in Discovery Live, we can quickly form our fluid domain by using existing geometries. For this simulation, we will use the existing enclosure. It's as fast as copying and pasting a surface from the existing enclosure so that we can pull and extrude it in the direction we need. Modeling the fans onto our fluid domain is quick and easy. We can project the fluid flow areas of the fans directly onto our fluid domain. Even if we don't have vents pre-designed, we can quickly conceptualize a vent pattern using the Discovery Live design features. Any sketches made on a surface will form split lines onto that surface. These split lines can be used to apply boundary conditions such as forces, temperatures, or fluid conditions. Now that we have modeled our boundary conditions, it's time to set a fluid solution in Discovery Live. We are given a few preset options for internal and external flow. Since we created our own fluid domain, we will unselect the presets and select the fluid domain we modeled. Discovery Live will use any existing geometry in the fluid domain to form a simple wall boundary on the geometry's external surfaces. Therefore, Fluid will flow around and past these existing geometries. After the fluid solution is initiated, we can start applying our boundary conditions. First, we will set a heat flow to the heat sinks. Each heat sink has a heat flow of 12 watts being generated from the PC processor. For the fans, we can apply an inlet or outlet condition using either a quantified velocity or a mass flow rate. For this simulation, we will use a mass flow rate taken from the fan specifications. For our vents, we will apply a pressure boundary condition. If we are working at atmospheric pressure, we will set our vent pressure to 0 pascals. We set a pressure condition to avoid over-constraining our solution. This allows the solver to calculate the mass flow rate on each individual vent, as it can vary due to location and geometry. With our boundary conditions completed, we can study the velocity and temperature flow of the system. We can see the fluid flow is not transferring the heat in an efficient way. The vents and fans are perpendicular to one another. This configuration minimizes the fluid flow over our heat sinks. Discovery Live also gives us many rendering options. Here we will use a field flow viewer to study the fluid flow over the heat sinks. With Discovery Live, we can make quick modifications for other possible configurations. Here we have a configuration with larger fans that flow air parallel to the PCB and heat sinks. We can quickly form our new boundary conditions using the power of Discovery Live's design tools. We're going to move the vents to the opposite side of the enclosure by simply using the move feature in Discovery Live. We'll follow that up by projecting our two 60mm fans onto the opposite side of our vents. Some of you may have noticed that Discovery Live does not import a traditional CAD design tree. This is what benefits Discovery Live. There are no CAD parent-child dependencies between sketches and features. Modifications and changes can be made quickly without causing fatal errors. There's no other design and simulation tool which allows you to make quick design changes and perform live simulation runs like Discovery Live. In less than 2 minutes, we have modified our previous design to quickly start a new simulation. Now that we've performed our design changes, we're ready to perform a simulation run. We can see the temperature is flowing in a more efficient path, which is being driven by our fluid flow. We have eliminated dead zones over our major computer components. Thanks to the various rendering options in Discovery Live, we can visualize these changes in 3D. Let's compare and look at the two configurations we've designed. The following table shows the average temperature around our heat sinks. With parallel flow, we managed to lower our temperatures by 10 degrees Celsius. With 7 hours before your design review, you can just sit back and have a nice cold one, thanks to Discovery Live. Today's webinar showcased a live simulation of a design and optimization of a computer server. We developed a method to remove internal heat generation by conducting and convecting it to a fluid stream. There's no other simulation software that can give you live results as you make design changes like Discovery Live can.
Wow. I think that's pretty amazing. If anybody wants to try Discovery Live, I'm going to bring my information back up again. Please give me a reach out either by email, by phone. I'd be happy to send you a copy. We'd also like anybody to answer or ask any questions, which we will answer. We have Eric from ANSYS with us, and we also have JD. So any questions? Let's take a look.
Oh, okay. They're asking about the mute or technical difficulties.
We should have more questions coming up in just a second. If you can't think of any questions now, though, you'd be more than welcome to either email myself or JD. Any questions? I don't see any questions coming up. I guess you did a great job, JD. Okay.
Okay.
All right. Here's our next webinar coming up next month. Again, this was a 6-part series. If you missed any of the previous webinars, we'd be happy to email you that recording, or you can find them on Kativ's YouTube channel. The next webinar coming up is ANSYS Discovery Live for 3D printing and design exploitation. And again, my email and contact information is there if anybody would like to try out Discovery Live. That's it.
Jessica's saying to check the chat. Let's see over here.
Oh, we do have some questions coming up here.
Hey, Eric, are you there?
Yeah, I'm here.
Okay.
All right. So first question.
So, so one of our panelists is asking about the accuracy and fidelity of Discovery Live compared to other ANSYS tools.
Okay. Do you think you can take that one?
Yeah, sure. So one of the advantages of Discovery Live is it's meant as a quick design tool. It's not going to have as accurate results as our other ANSYS tools. This is meant for the engineering designer to quickly make a quick design, so it cuts down that design validation verification with an analyst. So it's really meant to save time and for you to make a optimized design to save your analyst time. So you don't have to use too much of his most of the time the analyst is busy with other simulations. So I would say that. Go ahead, Eric.
Oh, sorry, I thought you were done. I'd just like to add that with the ANSYS other products, our flagship products, you can really reach any arbitrary level of accuracy if you're going to put in the time and the computing resources. With Discovery Live, there's sort of a maximum which is limited by your GPU. So if you have a good GPU, you can get more accuracy out of it. If your GPU is a little weaker, you're going to be more limited.
Okay. Another panelist is asking you if between the structural, thermal, and fluid, what kind of hardware do you need? Is there a difference between the three?
The minimum requirements for all of the types of simulation are the same. So 4 GB NVIDIA GPU. We do recommend more for the fluid simulations. They tend to require more memory to run. So with fluids, we recommend a minimum of 8 GB video memory. But for all types of simulations, the higher is better.
Okay. And then another panelist is asking, does Discovery Live have any reporting features? So you can take nice screenshots or save certain views.
There's no automatic reporting features. You can certainly take screenshots and record videos using other software.
Okay. And the last question here is, can Discovery Live be exported to any other compatible ANSYS programs?
So the models, you can modify models in Discovery Live, and then you can save those just as you could with ANSYS Space Claim. So into Space Claim format, which can be loaded into any other ANSYS product. The simulation setup can be exported into Discovery AIM, which is a next higher up level simulation for designers. Also very high accuracy. So once you've set up the simulation Discovery Live, you can save that, and AIM will import that with all the boundary conditions set up, which you can then run in AIM or add conditions, modify, set up a more complex simulation.
Okay, so someone's asking, what's the difference between AIM and Discovery Live?
Yeah,
they're both Discovery tools. That's why they're asking.
That's right. They're both Discovery. They're part of the Discovery suite, and they're for designers. We didn't get into that too much in this webinar. If you watch some of the earlier webinars in this series, we'll go into that a bit more. But Discovery AIM uses the same methods, the same accuracy as the flagship tools. So it's multi-physics. It includes structures, fluids, and some electronics capability. It just uses the more traditional meshing technology, just basically a higher level of physics. Not the same amount of capability as the flagship products, but it does give the same accuracy.
Okay, sorry, and there's one more question here. I guess people are excited about the software. They're asking about the solver for Discovery Live and AIM. What is the solver? Correct me if I'm wrong, but I believe it's Fluent. We're using a Fluent.
Not quite. It's in Discovery AIM. We're moving toward Fluent. So Discovery Live is its own solver. It's completely new, and it runs completely on a GPU. So it's not related directly to any of the other ANSYS solvers. Other than that, it's developed by ANSYS using all of the knowledge that ANSYS has gained over 40 years of doing simulation. But it's completely new. Discovery AIM, it actually is a combination of 3 solvers. So if you run structural simulations, you're using the same solver as ANSYS Mechanical. If you're doing electronics, you're using ANSYS Maxwell. Fluids, it is moving toward the Fluent, using the Fluent solver, but it's actually a different solver currently, but with the same, the same accuracy.
All right. Well, thanks, Eric, for your time, and thanks for your assistance.
Yeah, and I actually somebody just sent me an email about the 3D print and design we have coming up, part 6. If you have any interest with design and analysis of 3D printed components, that is what we're covering for part 6. It's really, you have to see Discovery Live's instantaneous analysis and directly integrated geometry modeling capabilities. It provides you with the ability to rapidly make changes to new and existing designs while simultaneously understanding performance trade-offs. So it's definitely a lot of fun, definitely a lot of interesting stuff will be on part 6.
All right.
All right. Thanks for attending, everybody.
Thank you.